Okay, so let's finish up the review. Number 7, graph the following function and show at least 2 cycles. So your amplitude on this would be 5, not negative 5. And we know our W is 1/8. Your period would be your normal period divided by W. And because we're doing secant, it's going to be 2 pi. And your W is 1/8. So think of this as 2 pi over 1. So 2 pi times 8 would be 16 pi. So our period is 16 pi. So what you're going to want is something from negative 16 pi to 16 pi for your window. And all of them match that. So then we just need to graph graphing from negative 5 secant 1/8 x. Okay, so right there you just see it's low, but we need to change our window to match this. And also all of them look like they go from negative 10 to 10 for y. And so let's just change our dimensions. So we go window, settings, negative 16 pi to 16 pi, and then this is negative 10 to 10. So there's our graph, and symmetric to the y-axis, like this, and so that's A. Any questions about that? So again, symmetric to the y-axis and below the x-axis. So try to rule out choices for graphs and also use your period and window. Okay, so then for your domain, we know it's going to be everywhere except where there's an asymptote. So 16 pi would have a number. You take half of that would be 8 pi, which would also have a number for a minimum. But then between 0 and 8 pi is 4 pi. So you'd have an asymptote at 4 pi. And between 8 and 16 is 12, so 12 pi. So I like doing it this way, and then you can see it'd be 4 pi k with k being odd. So in other words, 4 times 1 times pi is 4 pi, and 4 times 3 times pi, so that's 12 pi. So again, that's the way I prefer doing it. If you'd rather just go to your table, you can. I just think it's a little slower. So go to your window, table, settings, change to ask, and then I'll just put 1/8 and get a number. So I get a number there. It's negative 5 something. It's not all real numbers. And then when I do 4 pi, it's hashtag undefined. And 12 pi should be the same thing, but remember to interpret. Undefined. Interpret negative 5e to the positive 13 like this. And so it's a really big negative number, which indicates as an asymptote. So interpret that as hashtag undefined, like the 4 pi. And then for the one where it just says pi, you do that, you get a number, no e. So That's why it's C. Any questions? Okay, and again, if it's a cosecant or secant graph, you're going to choose OR. So that's B. And if you want to check it, below -5 and above 5. Any questions about that? Okay. All right. Next we have 6 cosine 6x plus pi halves. The amplitude would be the 6, which is here. Remember the W is the frequency, and so for your period it'd be the normal period divided by W. And since it's cosine, you'd have 2 pi over 6, which is pi thirds. Make sure you reduce those properly. I saw on the worksheet somebody didn't reduce 2 pi fourths properly. They put pi fourths instead of pi halves. So for the phase shift, that's going to be the phi divided by W. The tricky part sometimes is they put plus here, but you have to interpret that as minus a negative pi halves. And so you're going to get negative pi halves divided by 6. And I'm putting 6 over 1. So think of that as negative pi twelfths. So whenever it's plus, make sure you change it to minus, like minus a negative. And then you do right over left, which is the phi over the W. And then let's just graph it. By the way, here's another thing, like we've said yesterday. We got negative pi twelfths. Well, that is 2 of them right there, and we're not going to use the one that's the pi fourths. So we're down to 2 choices. Okay, so let's graph it, and we get 6 cosine 6x plus pi halves. And let's see, our period was pi thirds. Based on the graph, let's go like from x's from negative pi twelfths to like 5, and then y from negative 6 to 6. It's basically anything to the right. I just put 5 to put something. So go to your window, negative pi twelfths to 5, and then negative 6 to 6. Okay, so at negative pi twelfths, it's starting to go down like A. On B, it goes up. So I just look at the front. Any questions? Okay. So that was A. Okay, number 9. This one wants to know where cosecant is equal to 1. So if you want to, you can use your other circular functions handout. So remember, you have your unit circle, and then if you flip a couple of pages, there's sine and cosine, and here's this. And the one we're looking at is for cosecant, so that's there. The question is asking about where it's equal to 1, and so I can see that'd be at pi halves. Now, I'm not done with the question, but I know that from 0 to 2 pi, it shows up as pi halves, comma 1. Now, I realize in here it talks about colors, and so sine would be the red one, which is on the inside, and cosecant would be blue. But online it shows up right. It wants to know from negative 2 pi to 2 pi what's the smallest value. So there's your pi halves one, which is what I was talking about. But there's another one, and it's between negative 2 pi and negative pi. So it's halfway between, so that's negative 3 pi halves. Negative 3 pi halves. Now, if you did this on the calculator instead, you'd get cosecant x and where it's equal to 1. So I'm putting f2 as 1. And we want our window to be a trig window. So I'm going to go 8 there. So here you can either do minimum or you can do intersect. Menu, analyze. I'll do intersection. And I want between here and here, which is negative 4.71 something, and that's equivalent to negative 3 pi halves. If you don't like just coming up with a number, think about pi halves being 1, and then it's periodic, and so we're going to subtract 2 pi. So that means pi halves minus 4 pi halves, which gives you negative 3 pi halves. So that's an alternate way to get it, if you don't remember about the 4.71 being 3 pi halves. So whichever way works for you. Now about this one, it says the smallest value, so that'd be the negative 3 pi halves. And this one says the next, which is at pi halves. So the smallest is negative 3 pi halves, and then the next is pi halves. And it doesn't cross any other places, so you put there are none. There's no other places where it intersected where this would be at y equal 1. Any questions? So remember, 2 pi is equivalent to negative 4 pi halves. I was getting a common denominator of 2. Okay, next we have cotangent 1/12 x. So remember, cotangent generally slants down this way because it's a decreasing function. I ought to make that more curvy. It's generally like that. Now our W in this case is 1/12, and so our period would be normal period divided by W. Since it's cotangent, we'd have a normal period of pi, and then over 1/12, so then that gives you 12 pi. And so they're going to show 2 periods worth or more. It says 2 cycles or more. So anything that says 2 pi is wrong, and it's slanting down, so that's C. Yeah, your period's 12 pi. Yeah. There's asymptotes more often than there are on secant and cosecant.
So what about 10? What's the period for that?
Also pi. Yeah. So that's right there if you want to look at your sheet and circle it. For each, the period is pi for those two. Okay, so then looking at our graph, we have an asymptote at 24 pi. We take half and we get 12 pi. If you take half again, you get 6 pi, but that's an x-intercept. So we want 12 pi and 24 pi. So 12 pi is the winner. So basically 12 times 1 pi and 12 times 2 times pi. And again, if you'd rather use your table, you can. But I just use the concept of a half and go to where I need to. Any questions? Okay, then as far as the range, tan and cotan don't have any horizontal gaps, just vertical gaps, and so it's all real numbers. All real numbers for your range. Okay. Next we have number 11. Negative 7 secant pi thirds, and we want to graph it. So we know our amplitude's 7. We're reflecting the x-axis. And we know our W is pi thirds, so our period would be 2 pi divided by pi thirds. Secant and cosecant have period 2 pi, just like sine and cosine. So think of it as 2 pi over 1, and then multiply this, and you get 6 pi. And multiply this, you get pi, so then you get 6. And so rule out the choices that have negative 2 pi and 2 pi. Okay, then we want to graph it. And so basically our window is going to be from negative 6 to 6. And then our y part would be from negative 7 to 7. Bless you. So graph negative 7 secant pi thirds x. Okay, so it didn't show up because I haven't changed my window yet. So let's go to the window. I made a little mistake here. So negative 7 and 7 for y are where there's minimums and maximums. If you look at all of these, they go from negative 14 to 14. So I need to change my window to negative. Y min is going to be negative 14. And, well, let me just do that. And y max will be positive 14. Okay, so negative 6 to 6 and negative 14 to 14. Okay, so now you can see it, and it's symmetric to the y-axis, and it's down. So it's not this one. And that's it, because of that part. Any questions? Okay, so if 6 is there, take half to get 3. And between 0 and 3 is 1.5, which is the same as 3 halves. And between 3 and 6 is 4.5. So we want to look for the one that's 3 halves, and that's it, right there. 3 times 1 over 2 and 3 times 2 over 2. Oh, it says it's an odd integer. Sorry, 3 times 3 over 2. So this is 3 halves, and this is 9 halves. Any questions? Okay, then for your range, if it's cosecant or secant, it's going to be the OR. So it's B. So below -7 and above 7. Okay, number 12. This one we have a cosecant graph. Our W is 2 pi thirds. So our period would be 2 pi divided by 2 pi thirds. 2 pi times 3 is 6 pi over 2 pi. Just gives you 3. So for our x's, we want -3 to 3. And this one has -2 pi to 2 pi, so we know it's not it. Let's graph. We do have a vertical shift down. Okay, it's down 1. So, cosecant 2 pi thirds x, and then -1. So it looks like this, and I want my x's to be from -3 to 3. And the y's are -5 to 5. Okay, so to the right of the y-axis, it's up, basically, which is this one, and also this one, so it's not this, because that's symmetric. Now, the difference between B and D is B is shifted down like it's supposed to be, and D is not shifted down. And so that's how you know it's B. Any questions? Okay, so then with that graph, 3 is an asymptote, and then half of that would be 1.5, which we said is 3 halves. So that's C. And then the range would be the OR, which is below -2 and above 0. So think of this as start at the middle, like start at -1, and then you're going to go down 1 and up 1. So that gives you -2, 0. So there's your -2 and there's your 0. And you can see it up here too. -2 would be these, and 0 would be these. So anything below -2 or above 0. And also, I just noticed, if you do this part before this part, you pretty much can tell which graph it is. I mean, don't choose the one with 2 pi, but it's this one that's sitting on the x-axis. Any questions? Okay. Then tan pi force x, your W is pi force, so your period is your normal period divided by W, which in this case is pi over pi force. So that gives you 4. So a couple of these say negative 2 pi to 2 pi, and these go from negative 8 to 8, and negative 2 to 2. So we want tan pi force x, and we want to go from negative 8 to 8 and negative 2 to 2. Okay, so it goes through the origin because it's tangent, not shifted left or right any, and it's D. And as far as asymptotes, 8 has a number, so the middle is 4, which has a number. Between 0 and 4 is 2, which has an asymptote. And between 4 and 8 is 6, which has an asymptote. So we want 2k where k is an odd integer. So basically 2 times 1 is 2. And 2 times 3 is 6. And so that's B. And since it's tangent, the range is all reals. Tan and cotan have range all reals. Okay, number 14, 1/4 cotangent 1/6x plus 5. So our W is 1/6. Our period would be our normal period divided by W, which would be pi over 1/6. So that's 6 pi. These say 2 pi. Well, that one does. Okay, so then let's graph it. One-fourth cotangent 1/6 x and plus 5. Okay, so at this point it just looks like that, but all these have negative 12 pi to 12 pi. And from negative 20 to 20. Okay, so you can tell it's one of the ones that are decreasing in nature. Let's see, at the y-axis there should be an asymptote, and this one crosses the y-axis, so it's not that one. And then the choice between A and C is going to be A because this is wider. It's not that way for C. So the way I described it was it's wider on the turn since your vertical stretch is 1/4. Your 1/4 is in front, and so it's going to be a wider turn. If it were a whole number or positive, like 2, 5, whatever, it'd be steeper. But it slows down on the curve when there's a fraction in front, like 1/4. Any questions? Okay, then for your domain, at 12 pi it has an asymptote, and at 6 pi it does. And so here's your 6 pi k. and it says it's in integers, so 6 times 1 times pi and 6 times 2 times pi. There's your 6 pi and 12 pi. And again, range is all reals. Tan and cotan are all reals for your range. Okay, this one's a little bit trickier than you may think. I know it's just choosing a graph, but what we have is plus pi, so that's going to be minus and negative pi. Our W is 2 pi, so our period would be 2 pi divided by 2 pi, which is just 1. So because of that, I want to use a window from -1 to 1, and then just look at it. Whoops. Okay, so graph -4 secant 2 pi x plus pi. Okay, so there's your graph, and we want from -1 to 1. Just going to double click. Okay, so based on the window, it is symmetric to the y-axis and it's up, like this one. So that's the best approach on that one. Any questions? Okay. 16, this one your amplitude's 3, your W is 5. And so that means our period would be 2 pi divided by 5. Your phase shift, remember that's the right over left, it's phi over W, so that's pi over 6, divide by 5, putting it over 1, so then you get pi over 30. And that matches these. These say negative pi over 30. Okay, so then we want to graph it. Three cosecant 5x minus pi 6. Okay, so then we want our graph to go from pi 30ths to I'm just going to put 2. And then that's fine. Okay, so there's a little space and then it's up. Not this one because of this space. There's your little space. It says D. Any questions? Okay, then the last two. Are y'all good with those? Okay. Okay, so the last two, amplitude 9, period is told you this time instead of W. So we got to go W is the normal period divided by the period. So it's sine, so you want 2 pi divided by 7 pi, so you just get 2/7. Now the phase is the part where you remember before we said this phase shift is phi over W. But in this case we want to figure out what phi is. So phi would be the phase shift times the W. And so you go 1/7 times 2/7 and multiply the tops and the bottoms. So you get 2/49. Your phase shift is given this time, and you multiply by your W. Okay. And then on this one, our amplitude's 8. Our W would be 2 pi divided by 6 pi, which is 1/3. 2 pi divided by 6 pi is 1/3. Now here's why this one's a little tricky. They put a plus sign here, and so it's really minus a negative something. Okay, so watch out for that. Okay, so we're going to do phi is the phase shift times the W. Our phase shift is -1/5. Our W is 1/3. So we get -1/15. So we would say minus a -1/15. But this one put plus, and so you put plus 1/15. It's a bit tricky, but that's right. Watch out whenever they change it to a plus. Okay, so now you could work on your Math Excel review or study.